Hello you awesome people and welcome to this lecture. In this lecture, we will continue working on our deployment manifest from where we left it in the last lecture. But this name of the deployment file is bothering me because we are no longer in the step 0. So please let me rename it to web scraping deploy, something like this. We are good with this. Now, what is this warning we are getting here? Let me hover over it and it says one or more container do not have resource limits. This could starve other processes. Okay, so this is a warning. What this means is we have not set any limit on the container. So it can take whatever amount of CPU and memory which it wants to take. But it is not that your cluster will run only one single pod, right? There will be many container, many pod, many deployment and many namespaces which might be used by other teams in your organization. So your container cannot be allowed to take whatever amount of CPU and memory it wants to take and disturb other containers running in the same node, because without resource limits, a container can consume excessive CPU or memory resources, potentially causing resource contention with other containers running on the same node. This can result in performance degradation and instability across the cluster. A single container consuming all available resources can cause other applications to slow down or become unresponsive. When a container uses all available resources on a node without resource limits, it can impact the stability of the node itself. The node may become unresponsive or crash, affecting other pods and services running on that node. Yes, not just this, it will also cause difficulty in troubleshooting. Without clear boundaries, it can be harder to determine which pods are causing instability. By now, you must have realized this is clearly a challenge and Visual Studio Code is rightly pointing out this as a warning. Let's work towards solving this problem. So I'm executing this command kubectl top node. This command is used to display the CPU and memory usage of nodes in the Kubernetes cluster. We have just one node, so its utilization is being displayed over here. Then same command can be used in this way. So kubectl top pod. And with this, we get to see the CPU and memory utilization at the pod level. It is currently showing for the default namespace. If you want to really see for other pods also, we can pass this switch and it will show for all different pods running inside your Kubernetes cluster. Clearly, right now our CPU and memory utilization is not so high that it will create any problem, because what we are running is actually nothing. In BusyBox, these pods, our program is anyways ended already. Inside Nginx also, inside this pod also, you are not running much. It's just created for namesake. Okay, so seems like there is nothing problematic as of now. But if this pod starts taking like 95% of the memory, from where other pods will get the memory resources, right? That time your Kubernetes cluster is in problem. You don't want to run into the situation like that. For this reason, we want to set certain limit at the container level itself. Now, how to do this? Well, it is very straightforward. So at the container level, I'm typing R and this is the resources. We will deal with requests and limits inside this block. So I'll first say requests and we can specify CPU and memory. Resource requests specify the minimum amount of CPU and memory resources required by a container to run effectively. Looking at the CPU and memory being taken by the pod right now, 2 M of CPU and MB of memory, let's say. Okay, this much memory should be good because right now anyways it is not consuming this much. So at the time of starting the container, if it requests this much resources, I am completely okay with this. Okay, now let's talk about limits. So for limits also we need to set CPU and memory. By setting resource limits, we define the maximum amount of CPU and memory resources that a container can consume. Honestly, to come up with the limits, you need to understand what exactly that pod is expected to do. In our case, we don't really have much to do, so I'm just setting it to 20 M and 50 MI, which is like 10 times of what it requests initially. And I am sure my container should not need more than these many resources. But for your real world application, you want to see what exactly that container is expected to do, and accordingly you want to come up with the values for this CPU and memory in requests and limits, right? Let me save this. Beautiful. Now let me tell you, not every single time we will have this URL and this file name only. URL can change, which we want to scrape and store in another file with that particular website name. Essentially, as per this deployment definition, what we want to say is, whenever there is need to scrape another URL, you delete the pod and recreate it. Does it make sense to you? No, right? It is not a good system. Hard coding should be avoided wherever possible. We should definitely work towards avoiding it. But when? Well, let's do it right now. Yes, we have a concept of environment variables in Kubernetes, which are used to provide configuration and runtime information to containers running within pods. They allow you to pass dynamic values to your application without modifying its code or configuration files. Without getting into too much of theory, I'll say this is the scraping URL whose value I'll get from somewhere, but it is not hard coded anymore. Same I am doing with the file name. So this is not my file name. My file name is this, and this is a variable whose value I'll get from somewhere. Okay. Now, because this value will come from somewhere, it perfectly makes sense to type those values in this, so that these values are printed and making it comfortable for us to see what values were actually passed over here. For this reason, I have added these two lines. Okay. Now, from where these values will come? Of course, we have to specify it somehow. So we will do it with the help of environment variables. Let's do it like so. Let's work on this. So it has to be ENV, and then we have to specify the name. Name is nothing but the name we have used here. Okay, so same name we have to use. Okay, and we can give whatever value we want to give. So I'll say we used TechSckool earlier, so I'll use Stack Overflow. Okay, and there is one more value that we need to pass to this. Let me create another environment variable, and this is file name whose value is stackoverflow.html. Yes, so this way we are specifying these values over here, and scraping URL and file name, these values will be provided to this code, which will take it from here. You might be thinking this still doesn't solve the problem completely. I just want to break the problem into several steps so that you understand very clearly. Okay, so let's continue with this. I'm saving it. Okay, our pods are running. I want to make one more change here. Sorry for the confusion. I took this replicas example just for your understanding. We don't need it anymore. I'm just changing the count to 1. It doesn't serve any purpose to have 3 pods for this, right? So I just want to make it 1, and I'll get rid of unnecessary pods. Applying the YAML file again to create the deployment, and let me get the pods. Okay, this time we will see only one pod getting created as a result of this, and our pod is created as well as it is in the running state now. Let me describe the deployment. You can see earlier we had set the limit and requests, so those are available over here. So you can take this as a confirmation that indeed our request and limits are applied. Okay, this is one thing. And second thing is our environment variables are created over here. And all of this is at this particular container level. So our the name of container is busybox, and inside this we have limit, request and environment variable also created now. Whether these values are actually available inside the container which we created is a different story, which we have to separately validate, right? So let's do that also. So what we will do for this is revisit the same concept which we did earlier. kubectl execute -it. I want to connect to this particular container. So what is happening here is we are specifying the pod name, but we are actually getting connected to a particular container. There can be multiple containers within this pod. How this is happening? Well, it's very simple. We are specifying the name of pod, but since there is only one container, Kubernetes is directly letting us connect with that without even having to specify its name, right? If there are more than one container, you want to specify the name of particular container over here, and then you will be connected to that. Okay, let me specify the shell, hit enter, and we are inside the container now. So let me say print env. Print env is a command in Unix to print the environment variables within the host, and we can very clearly see scraping URL is created as an environment variable, as well as a file name environment variable is created over here, which are served to our code. And definitely our code running inside this host has made use of these environment variables, because as a result of it only this file got created. Moving on. Remember, we added these echo statements. There has to be some use of these also, right? Because we don't do anything without any reason. Yes? So let me show you what is the use of this. kubectl logs, and if I give the name of this pod, hit enter, you can see as a result of these echo statements in our command, we are seeing this in our logs output, with which we can validate what are the actual values of scraping URL and file name that were passed to our command. This is super cool, isn't it? Alright my dear friends, in this lecture we learnt about resource requests and limits, as well as we got introduced to the environment variables, and with the help of these we have soft coded our logic for web scraping. In one way or other we are still doing hard coding over here, which is definitely not good. I do not support it. So let's meet in the next lecture and continue working on this. See you there. Take care. Thank you.